Hello, and what we're going to do in this particular video is teach you how to convert polar coordinates to rectangular coordinates. Now, a lot of CNC mills, specifically the more advanced ones with more sophisticated controls, will actually let you input coordinates or input polar coordinates, though the majority will not. They want their coordinates input in rectangular. Now, when we talk about polar coordinates, usually we're talking about bold hole circles. This is an example right here. We're going to use this part as an example. We've got these bold holes right here, and this is a bold hole circle. Again, there's just a tons of uses, thousands and thousands, if not millions of uses of bold hole circles. Probably the most popular one is the way we keep your tires on your car, okay? Or, the bolt pattern 5, 4, 6 in some cases, God knows what. I don't even know how many a semi has, 18, 20, who knows. Bottom line is that it's a bolt hole circle, okay? So it is given to us in polar coordinates. And the reason they do that is for them to give you the actual honest to God distance from the center, and that's what we're going to do is the center in this particular situation is going to be x0 y0. For them to give you every one of these moves, there'd be so much dimensions on this print you could not read it. So what we do is it's much easier and much plainer to dimension it using polar coordinates and then convert those to rectangular. That's just the way it is. This is going to be English, okay? So let's just look at the bold hole circle. First off, this is a typical designation here. We have this quarter-inch diameter holes through. That means they go all the way through the part. We can see it down here in the cross-sectional view. They go all the way through the part. And they're on a 1.75 diameter bolt hole circle. Now this says B bolt circle diameter. All right, there's just a lot of different ways. BHC would mean bolt hole circle. Bottom line is that this center line, okay, that's going through these holes, this circular center line, this is a bolt hole circle. Now he's calling it a bolt hole, whatever he's calling it. This guy is a little bit different in his dimensioning. He does say they're 12 equally spaced. So I'm going to read that again. So all these holes are a quarter-inch diameter through, and they're on a 1.75 bolt circle diameter, and there's 12 of them, and they're equally spaced. Okay, so what's the first thing we have to come up with? Well, we have to come up with what the angle between each one of these holes is. So the first thing we do is, there's how many degrees in a full circle? I'm actually sitting here waiting. Okay, I know you're not going to tell me, so there's 360 degrees. Okay, so if these are equally spaced, we just divide that by the number of equally spaced holes. In this case, it's 12. So each one of these holes are 30 degrees apart. That means, and I'll do that, it's 30 degrees from there to there, 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 etc. Okay? Now, we don't have to calculate all of these holes up. This one, this one, this one, and this one are given to us. I'm going to show you. This one and this one are going to be the inverse of each other. Inverse may not be the right term, but I'm just going to use it, okay? Maybe the reciprocal. I'm just going to use that term. It's probably not the right mathematical term. So let's go ahead and say the first thing we're going to do is go into our scientific calculator. There we go. All right, so let's get that down here where we can see. I've got a nice little coordinate chart here. We'll say this is hole number 1, and we're going to go clockwise all the way around to hole number 12. All right, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So holes, that hole, that hole, that hole, and that hole are all going to be given to us. So let's just do those real quick. Remember, we're working with x0 and y0 in the center of the part. This would require a coordinate shift if you're using this corner, this corner, this corner, this corner. It's the best way to do that. So go with the G55 and set up the center of the part. Or wherever this is. It's 2 inches in X and 1.5 inches up in Y is where the center of this bolt hole circle is in this particular part. So you would set that up and use a G55. Hopefully, we did that in another video. I believe it was 7. It was either MillLab 7 or MillLab 7A. Check them out. It'll show you how to do a coordinate shift. So now that we've explained all of that, what I'm going to do is show you the first easy holes. I think I talked about this earlier. That would be hole number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Never hurts to make sure that you do have 12. It says there's 12 here in a 1.75 diameter bolt circle diameter, which that's that right there. Anyway, we've gone over that. So this is going to be hole number 1, 2, 3, 4. So hole number 4, hole number 1, hole number 4, 5, 6, 7, 8, 9, 10. So 1, these are already given to you. They don't require any calculations. So all we have to do is we can see again, remember x0, y0 is in the center of the part. Okay, so that's what we've done. We've shifted it to the center of the part. We just need to know how much to go up because x is 0. So I'm going to put 0 right here. All right, you don't have to use all three of these numbers obviously in your program, but I'm just putting up there. Makes it a little easier for people to see. All right, so let's go, and the y. Well, y is simply the distance from here to the center of this bolt hole pattern, bolt hole circle, uh, bolt hole diameter, whatever you want to call it. It's basically called a bolt hole circle. So the radius of the bolt hole circle, if we look at it, it's 1 inch 750 thousandths. So if we go 1 inch 750, 1.75 divided by 2 equals 875. So to get up to the center of this hole from the center of this pocket, which is the center of the part, I only have to move 875 thousandths. Now let's tab that over, 0.875. So that's the first one. So let's go to hole number 4 here, tab. Now this time, x is going to be, well, I'm moving from here to there. So x is going to be 0.875, and tab and y is going to be 0. Okay? Okay, so that was hole number 4. So 1, 2, 3, 4. So the next one is 7. We want to do hole 7. These are givens. These are our givens. Basically, x again is 0. And y is going to be minus 0.875. Now remember, because we shifted our origin to the center of the part, so anything on this side of y, remember this is the y-axis, this is the x-axis, this is x0, y0. Anything down here is y minus. So that has to be a minus value. Don't forget that, or you're just going to end, if you put that in a program, you're going to end up drilling a hole right there again. Okay, so the last one I believe is, like, see, that was 7, so 8, 9. Hole number 10 is the last one we need as far as our givens. This time, x is going to be, again, we're on this side of the origin, so this is minus, this is plus. So x is going to be minus 0.875, and we'll tab over, and y is going to be 0. Yeah, so that is the givens. Now what we're going to do is we're going to go ahead and get into the rest of the calculations and use, trigonometry to figure out the locations of these holes. Okay. Neat thing about it is these holes are reciprocal, inverse. We don't have to do a whole lot with them. Now I want to show you that again. I'm going to go back into view and go into scientific. There you go. I like my TI-85 for this, but that's fine. So first off, we did that. We said each one of these holes was how many degrees apart? Well, we took 360 divided by 12. We'll just do it again. Ain't no big deal. 30 degrees apart. There. So how do I come up with how far I got to go over in X and how far I got to go up in Y to get to hole number 2? So I'm going to go to number 2 here, tab it over. Okay, bring that back up. Now we're all ready to go. I think we are. We'll see. So I've got 30 degrees in there. One more time, I'll do that one more time just to show you how I did it. Since they're 12 holes equally spaced, 360 degrees in a full circle divided by 12 equals 30. Now, I'm going to use the sine of this angle, the sine of 30 degrees, and the cosine of 30 degrees interchangeably. If I take the sine of 30 degrees and multiply it times the radius of the bolt hole circle, which is 0.875, and I take the cosine of 30 degrees and multiply it times the radius of the bolt hole circle, which again is 0.875, that's going to give me one or the other, or it's going to give me both of them, and they'll become which one's obvious. Let's just do this one for hole number 2. Okay, so we know we got 30 degrees. So if I hit 30 degrees sine, it should be 0.5. It is. I know that one. That one's pretty easy to remember. Now we just take it, multiply it by the radius, which is 0.875, and I get 0.4375. Well, it doesn't take a whole lot of judgment to see that the distance from here to there is probably 0.4375. It sure isn't this one. So I'm going to go up here. That's my x value for hole number 2, 0.4375. Do not, by the way, please do not round that. Now let's do this again. I'll clear it all out. I'm going to put 30 in there again. And this time I'm actually just going to go ahead and store that in memory because we're going to use 30 over and over again. This time I'm going to take the cosine of 30 degrees, which is a huge number, and multiply it again times what? The radius. Yep, 0.757. Round this to 4 places, 0.7578. So 0.7578. Let me double check that. 0.7578. Yeah, that'll be fine. Okay, so I'm going to clear that out. Great. So there you go. Now, that's the coordinates of hole number 2. What about number 3? Well, the distance from this hole to this hole is 30 degrees. So it's basically the same thing. All we have to do, folks, and I'll show you how, I'll prove it, but we just have to reverse them. Like I said, it's either the inverse or the reciprocal. I hate the English language. Reciprocal and inverse actually isn't English at all. I'm pretty sure it's Latin. But let's just do it, okay? So, how far do I go up and how far do I go over? So let's do x first, or let's try to do x first. Anyway, let's go memory recall, bring back our 30, and let's do sine, which is 0.5, and multiply it times what? The radius, which is 875, 0.4375. Well, up here we know there's no way, so it's 4375 and y. So that one, see, in this case, the sine of 30 degrees did not give me the x value. The cosine gave me the x value. So I'll show you that again. Let's clear it back out. So let's try 30 degrees. Let's hit the cosine. Okay. Multiply that times the radius of the bulbhole circle. Okay, 0.7577, which we said was 0.7578. So say we go here, tab that over, and actually, here's the beauty of this. Yep. And you know what? Do you know what the y value is? I bet you already do. They're just inverses, so you're saying, well, you just did it. I'm going to clear it out again. 30 sine times the radius of the bulbhole circle, 0.4375. Okay, now we can keep doing that. I can do this for all of this, you know. So let me see, 1, 2, 3, 4. I would just put that in hole number 4. No, I just put that in hole number 3. So what about hole number 5? Let's do hole number 5. Here, get it tabbed over. Bring up our scientific calculator, clear that out. Boom. We still got memory recall 30. So I should do, I think we decided that the cosine of 30 degrees would give me the x value. So let's go 30 degrees and hit cosine. There it is. Again, multiply it times 0.875 equals, yeah, 0.7577. So we're going, that's how far over it is. Well, yeah, it's right in line with that hole right there. So yeah, that makes sense. You're going, but wait a minute. I'm just going to copy this. There's something a little, see, this is fine. Paste. Okay. And I'll do it again for y. Clear it out. Memory recall. Sine times the radius of the bulbhole circle. Now, if you haven't noticed it, there's a pattern starting to develop here. You only had to do one trig problem for this one. You really did, just one. Okay? So I got 1, 2, 3, 4. Hole number 1, hole number 2, hole number 3, hole number 4, hole number 5, and 1, 2, 3, 4, 5. So let's do hole number 6. Tab it over, bring up the calculator, go ahead and clear it. Okay. Now, this time I'm going to bet you that the cosine that the sine of 30 degrees, excuse me, so memory recall, let's bring back 30 degrees. Sine times the radius, it's always going to be times the radius, 0.4375. Yeah, it looks like it's 437 thousandths from there to there, sure. So we go back up here, and again, you probably notice a pattern. Now, I can go back over here. I'll do it again for you, but I think by now you're probably getting it. What are we going to do with that one? We're just going to go ahead and clear this out. 30 degree and cosine times 0.875. It should be the same answer every time, which is we rounded that. So I'm just going to copy this because that's the right answer. Copy. And go back over here, paste it right here. Paste. See? And Control S. I haven't done that for a while. Now, so we're given hole 7. 1, 2, 3, 4, 5, 6, 7. We've already got it down here. Hole 8. Well, let's do hole 8. There's a problem. We're going to, remember, these are quadrants. Here's a quadrant right here. Here's a quadrant. Here's a quadrant. Here's a quadrant. Quadrant, 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 quadrant. X and Y will be positive. X will be positive. Y will be negative. X will be negative. Y will be negative. X will be negative. Y will be positive. Okay? There's another thing, all sin, tan, cos. All right, we'll not worry about that just yet, but that's another little trigonometry trick. Once you get, I really don't have to calculate these out. I can just look at it and say, okay, see, I only really had to do one trigonometry program. All right. In the interest of time, though, or not in the interest of time, but just so that I'm doing a good video, we'll go ahead and complete it. So we're ready for hole 8. Tab. Love the fact that the calculator disappears. There's probably a way to keep that from doing it. I haven't figured it out yet. I think I say that every single time it does it. So this was hole 7, so this is hole 8 right here. So I'm going to go, you know what? All I have to do is reverse the signs. It's the same as hole 6. It is. I prove it. So 30 degrees sine. So let's go memory recall and hit sine button. There's the sine 30 degrees. Multiply it times the radius of the bolt hole circle, 0.4375. Now, if you put down 0.4375, you're wrong. You're going, what? That's because I told you x0 and y0 is in the center of the part. That's how we always do bolt hole circles. So it is a negative value in this case. So don't forget to put that negative sign up there, otherwise you'll drill this hole again. Okay? Negative 0.4375. Let's tab over here. Now, clear that out. Memory recall. And I believe this is going to be the sine of 30 degrees times the radius of the bolt hole circle. No, that was the one we already did. It gets confusing sometimes, so I'll clear that back out. It is the cosine of 30 degrees. Oops, screwed that up. You got to, in this calculator, you got to put it in first, and mine you got to put it in after. It's weird, but anyway, memory recall. And let's see, cosine. Okay. Times the bolt hole circle, the radius of the bolt hole circle, excuse me. Yep. And this one also is going to be a minus value. So you can just copy this because we know this is the right answer. Don't forget the decimal point. Copy. Paste it right here. Paste. And then I'm going to put a negative there and hit Control S. I'm not going to do the rest of these. Okay? You don't need me to do the rest of these. You can do them all yourselves. Matter of fact, you don't. Once you're done on this particular bolt hole circle, once we did this particular hole, this one is the inverse. This one and these two are the inverse or reciprocal. It just works that way. So remember, it's a very simple formula, okay? And I'm going to write it down here, okay? Sine. Let's try it here. Sine of the angle multiplied by the radius is going to equal one leg. Now, which one it works? I don't know. Now I'm going to copy this whole thing because you know me. Oh, I screwed that up. Now, watch this. There. So this is going to equal one leg. That'll equal another. And then you just kind of look at them, Control S. That is one of the most useful little formulas. You don't even have to look it up in a trig book. Remember, just take the sine of the angle times the radius. You'll get one side. You'll get one coordinate, either x or y, and the cosine of the angle times the radius will give you the other coordinate, whether it's x or y, and just kind of look. Now, if you got more holes than that, it gets a little more difficult. You may have to do two or three more different ones, but that is it. That's as simple as it gets, and there's no reason to get out the trig book for this one. This right here, okay, that is something you should commit to memory because you're going to do a lot of bolt hole circles if you're going to be any type of CNC person at all. That's all there is to it. All right, like I said, Control S. All right, thank you very much. You have a good day, and I'll see you all later.